This lecture we will discuss regarding some numericals based on the multi-level gas. Okay. So first you should know what are the formulas for the multi-level gas. So here we are talking about the two-level gas. Okay. So CPU, then L1 gas, then L2 gas, then your main memory. Okay. So what is happening when the first CPU generates a request, it will searches in L1. If it is fine, then it's okay. Pass to L1. If it is not there, then it searches in L2. If it is there, then pass to the CPU. Otherwise, it will search in the main memory. Okay. So one thing. So when you are not finding in the L1 gas, then we call it the miss penalty of L1. Okay. How much time? So miss penalty of L1. So now we are talking about what is the miss penalty of L1 and miss penalty of L2. See. So say if it is not there, then how much time will extract from the main memory? So miss penalty of L2 is equal to the what? Main memory access time. Main memory access time. Okay. Now some scenario will come. Let's say without L2 case. Okay. Without L2 case. That means what? The miss penalty here without L2 will be without L2. Then miss penalty of L1 will be what? Main memory access time. Okay, so based on this we solve the numericals. So you should know about this. Okay, so first average access time, hit time of L1, we search in the L1 case. If it is the chances of not there, that is miss rate of L1, then miss penalty of L1. Now we are involving the L2 case, so our miss penalty of L1 will be what? Hit time of L2, L2 case, then miss rate of L2 case, then miss penalty into miss penalty of L2. So it will combine. Then average memory access time will be what? Hit time of L1, miss rate of L1, multiply with hit time L2 plus miss rate L2 into miss penalty L2. Okay. Now, so one more thing. So local miss rate, global miss rate for the L1 case is same. But for the global miss rate of L2 is equal to what? Local miss rate of L1 into local miss rate of L2. So we will see through the numericals what is the meaning. Then another formula you should remember. Average memory stall cycles for instruction will be miss for instruction in L1 into head time L2 plus miss for instruction L2 into miss penalty L2. Or can another formula is there for the same thing. Average memory access time minus head time L1 into average memory access for instruction. If you miss for instruction, so you should use this formula. Otherwise, if you are calculating the average memory access time, then you can use this formula. Okay, so we'll see some numericals. Okay, based on this, and also regarding this, what is this main miss penalty of L1 going to be main memory access time? That means miss penalty of L1 is equal to miss penalty of L2 when there is no L2 case. What is the meaning this? Miss penalty of L1 is equal to miss penalty of L2 when there is no L2 case. If this case is not there, then what is the meaning? Miss penalty of L1 is equal to what? Main memory access time. So what is main memory access time? Miss penalty L2. Okay. So we should use this one. Okay. So we'll see some numericals based on this. So now we'll see the examples. Okay. So here for 1000 memory reference, 40 misses in L1, 20 misses in L2, and L1 hit time is 1 clock cycle, L2 hit time is 10 clock cycle, L2 miss penalty is 200 clock cycle, 1.5 memory reference for instruction, and the ideal CPI is 1.0. So find local and global miss rate of L1 and L2 case. mix rate of L1 and L2 gas, along with find average memory access time and average stall cycles for instruction. So first we will see how to calculate this local miss rate and global miss rate for L1 and L2. So as we know that from 1000 memory access, 40 misses in L1. So what is the miss rate of L1? So local or global miss rate of L1 is equal to 40 miss for 1000 memory access. Okay. And what is the local miss rate of L2 gas? So local means, so 40 means in L1. So these are will go to the L2 gas. So that means 40 is now local. So 20 out of 40. 20 out of 40. From the 40 memory access which are missed in the L1, that will go to the L2. So that means you are getting the 20 misses in L2. So out of 40 misses in L1 gas. So if you are talking about the global miss rate of L2. So you are getting 20 miss in L2, but what is the total memory access for a program? 1000. Okay. So if you can verify this answer, then formula is what? Global miss rate of L2 is equal to local miss rate of L1 into local miss rate of L2. Just check it. 40 by 1000 multiply with 20 by 40. So which is equal to 20 by 1000. Yes or no? So either you can remember the formula or you can directly find this right. Now comes to the calculation of average memory access time. So before that average memory access time, we should know how many instructions are there. How many instructions are there? So here it is number of memory reference is 1000. Okay, and in one instruction we are accessing 1.5 memory access. So number of instruction is equal to what? So how to calculate? That means in one instruction, or you can say 1.5 memory access in one instruction. So in 1000 memory access will be how many instructions? 1000 divided by 1.5 number of instruction. This much instructions you have. 1000 divided by 1.5. Okay. Now we will see average memory access time. So to calculate the average memory access time, so formula is heat time of L1 plus miss rate of L1 into miss penalty of L1. So miss penalty of L1 is what? Heat time of L2 plus miss rate of L2 into miss penalty of L2. Just put the values. So heat time of L1 is given 1 clock cycle. So miss rate of L1 is 40 by 1000. Multiply with heat time of L2 is 10 clock cycle plus miss rate of L2 is 20 out of 40. Multiply with miss penalty is 200. The question is what you will take in this place, whether local miss rate or global miss rate. Okay. In miss rate of L2 is here is local or global. We will take the local one. Why? Because so if you multiply this miss rate of L1, miss rate of L2 will act as the global miss rate. Yes or no? So when you open the bracket, it will act as the global miss rate. So just remember, when you are applying this formula, what will put local miss rate of L2. Got it? So this is what your calculation of average memory access time. The answer for this 5.4 clock cycle. Now we'll calculate what? Average stall cycles per instruction. So for the average stall cycles per instruction, what is the formula for that? Average stall cycles per instruction. Formula is miss per instruction in L1, miss per instruction in L1 multiply with heat time L2 plus miss per instruction in L2 multiply with miss penalty L2. Now, so how to calculate this miss per instruction in L1? So in L1 we are getting 40 misses out of how many instructions? Number of instruction is what? We have calculated here 1000 by 1.5. Okay. So in L1 case we are getting 40 miss. So for this much instruction we are getting the 40 miss. So for one instruction you will get how much miss? 40 by 1000 into 1.5. Now same for the L2 case. In L2 case we are getting 20 miss for 1000 by 1.5 instruction. So for one instruction how much you will get? 20 into 1.5 by 1000. Yes or no? So just put these values here. So miss per instruction in L1 is 40 by 1000 into 1.5 into heat time of L2. Heat time of L2 is 10 plus miss per instruction in L2 20 by 1000 into 1.5 into miss penalty of L2. Miss penalty of L2 is 200. Okay, so just put these values and you will get the answer. See, miss per instruction is this one 40 by 1000 into 1.5. Heat time is 10 clock cycle. Miss per instruction in L2 is 20 by 1000 into 1.5. Miss penalty is 200 clock cycle. So the answer is 6.6 clock cycle. 6.6 clock cycle. Okay. So in this way also you can calculate. Another way, the second formula. So for this, so average stall cycles for instruction. Directly I am putting the value. Average memory access time, which is 5.4 minus cache seed time 1 multiply with memory access per instruction. Memory access per instruction is 1.5. You just put these values, you get the same answer, that is 6.6 clock cycle. Okay. So just take the glance regarding this, what we have done in this example. First we are finding the local and global miss rate of L1, which is the same. So out of 1000 memory access, we are getting 40 miss. Then local miss rate of L2 is 40 misses in L1. So that will reference to the L2. So and we are getting the 20 miss in L2. So 20 by 40. So that is the local one. So when we are talking the global miss rate of L2. So from the total memory access 1000, from that we are getting 20. So 20 by 1000. So you can verify this answer by using this formula, that is local miss rate of L1 into local miss rate of L2. Now just come to the calculation of average memory access time. So to calculate the average memory access time, what is the formula? Heat time of L1 plus miss rate of L1 into heat time of L2 into miss rate of L2 into miss penalty of L2. So one more confusion in this part, that in miss rate of L2, which thing will multiply, which thing will put, whether local or global. As you are multiplying with miss rate of L1, miss rate of L1 and miss rate of L2 will become what? It will multiply and it will become global. So that means it is talking about which miss rate? This is a local miss rate, or you can just mark it. This will be local miss rate of L2. Just put the values 1 plus 40 by 1000 into heat time of L2 is 10 plus 20 by 40 into 200. You will get the average memory access time. Now, for the second one, average stall cycles for instruction. So there is two formula. So one is miss per instruction in L1 into heat time of L2 plus miss per instruction L2 into miss penalty L2. So first you should know how many instructions are there. Okay. Number of instructions is not given explicitly. You should find out how many instructions are there. So as it is given 1.5 memory access per instruction, that means 1.5 memory access in one instruction. So total memory access we are doing 1000. So that means number of instruction will be what? 1000 divided by 1.5. So this much instructions are there in the program. So for the miss per instruction in L1, so for this much instructions are getting 40 miss. Okay. So for one instruction, how much miss? So 40 by 1000 into 1.5. Same for the L2. So for the one instruction, you will get 20 by 1000 into 1.5. So just put these values and you write 6.6 clock cycle. The same thing, you just calculate by using another formula, that is average memory access time minus cache hit time multiply with memory access per instruction. Okay. You just put it and you will get the 6.6 clock cycle. Okay. Now we'll see the another example. Okay, based on these formulas. Now we'll see another example for the multi-level cache. So here the previous questions that are the same. Only the difference is here L2 miss penalty is 100 clock cycle, and we are calculating the average memory access time and stall cycles for instruction with L2 cache and without L2 cache, and we will also compare the performance with L2 and without L2. So for that, what is the local miss rate, local or global miss rate of L1, that is 40 by 1000. Then local miss rate of L2 is 20 by 40. Then global miss rate of L2 is what 20 by 1000. Yes or no? Next, we will find out what average memory access time. So average memory access time is what? So I am not writing the formula, directly putting the values. Cache hit time of L1. So cache hit time of L1 is 1 plus miss rate of L1 cache 40 by 1000. Then cache hit time of L2 10. Miss rate of L2. So you put this one 20 by 40. Then miss penalty of L2 is 100. This much you will get in the average memory access time. Then, if it is involvement with L2 cache, with L2, average memory access time with L2. Can you calculate what is the average memory access time without L2? There is no L2 cache. So how to find out? So cache hit time, miss rate of L1, that is 40 by 1000. Okay, as there is no L2 cache, that means the cache hit time of L2 is not there. So for getting the miss in L1, you will go to the main memory access time. So what is the main memory access time here? That's the miss penalty of L1 here. So for this case, miss penalty of L1 is equal to miss penalty of L2 which means main memory access time. Just to understand this one, already I have discussed this one. So what it will put? Miss penalty of L2. So what is the miss penalty of L2? 100. Actually this 100 is L2 miss penalty, means it is your main memory access time. Okay. Yeah, you just, this is the what? Average memory access time with L2 and without L2. The answer for this one is average memory access time without L2 is 5, and for this one is average memory access time 3.4. 3.4. Now we'll see how to calculate this average stall cycles for instruction without L2 case, average stall cycles for instruction with L2 case. So average stall cycles for instruction without L2, average stall cycles for instruction with L2. So just put the various formulas. What's the formula? Formula is average memory access time minus cache time multiply with memory access per instruction. So what is average memory access time without L2? Without L2. Acha. This is with L2 and this is without L2. Okay. So what is the with L2? 3.4. So 3.4 minus cache time is so cache time means it is talking about L1. Cache time of L1 is 1. Multiply with 1.5. So for this one, 5. Average memory access time without L2 is 5 minus 1 into 1.5. So the answer is 6. 3.6. Okay. Now let's see the CPI time calculation. So CPI will be what? CPI with cache, with L2 cache, and CPI without L2 cache. So what is the CPI with L2 cache? So ideal CPI formula is what? Ideal CPI plus this average stall cycles for instruction. Just put the values. So ideal CPI is given 1. So 1. As you remember, with L2 case, with L2 is 3.6. It is 4.6. CPI without L2, so ideal CPI is 1 and it is 6. That is 7. 7 clock cycle, 4.6 clock cycle. See. Next question is compare the performance. So performance will be the division of this one. Performance will be seven upon 4.6, which is equal to 1.52. Okay. Just see what we have done here. So already you know how to calculate the local miss rate, how to calculate the global miss rate. That part will not cover. Now discussed. Then average stall cycle for instruction. So how we are calculating with L2 and without L2. In with L2, average memory access time minus cache set time L1 into memory access for instruction. So average memory access time already we have calculated. So here, okay, average memory access time with L2 is what? Cache time of L1 plus miss rate of L1, then involvement of L2. So cache time of L2, then miss rate of L2, then miss penalty of L2. That is 3.4. Now without L2, so cache time plus miss rate of L1. So as there is no L2 case, so for each miss you will get the miss penalty. That means miss penalty of L1. So here this penalty of L1 is not given directly. So what we will calculate, as there is no L2 as here we consider there is no L2 case, then this penalty of L1 will be main memory access time. So what is the main memory access time? That is given in the miss penalty of L2. So here miss penalty of L2 is 100. So you just put the values. So you just put the values everywhere and you will get the answer for the average memory access time without L2. Then same the average stall cycle for instruction with L2. You get 3.6. Here you get average memory stall cycles for instruction without L2. You get 6. Then CPA calculation for without L2 and with L2. So with L2 is 4.6 clock cycle and without L2 is 7 clock cycle. So we can see that which one is the better with L2 case. I mean multi-level case is better. Okay. So just compare the performance. So without L2 and with L2. Just divide that, you will get the comparison.